Now in this slide, we are going to look at one example of latent heat. Alright. Okay. So what mass of steam initially at 130 degrees Celsius is needed to warm 200 gram of water in a 100 gram glass container from 20 degrees Celsius to 50 degrees Celsius. Right. Now in this question, I prefer to draw a graph of T versus Q. Okay, for both steam and water and also glass. Right. Now, initially the steam is at 130 degree Celsius. Alright, so we are going to put it in a warm water. Right. Jadi, okay, sorry, we are going to put in water. Okay, to make it to increase the temperature of water from 20 to 50 degree Celsius. Alright, so as we put the steam into the water, the temperature of the steam will decrease, alright, until it reach the boiling point of water, that is 100 degree Celsius. Right, after that what happened? Okay, the nama ni Q, right? So the Q added, okay, to the system, no longer to change the temperature but to break the molecules, the molecular bonding of steam, right? And then continuous heat added to the system, right? So you can say that after the steam completely change phase to water, right, the temperature will decrease again until it reach 50 degree Celsius, right? So 50 degree Celsius is the final temperature, right? 50 degree Celsius. Right. So as for the steam, right, from 130 degrees Celsius until it reach 50 degrees Celsius require 3 segments, okay, ataupun 3 steps, right? So kita ada kata tadi 1, 2 and 3, right? So the energy required to decrease the temperature of steam from 130 to 100 degrees Celsius is mc delta T. Right, so here we have mass of the steam, the one that we are going to find out, and then C for the steam, and then delta T. So delta T is 100 minus 130. Right, so this will be the final temperature. Dekat sini initial temperature. Okay, ni Ti, ni T final. Alright, ni T final untuk yang the first region ni. Okay, alright, so the specific heat of steam is 2010. Right, so mass and then 2010, and then this will be negative 30 degree Celsius. Alright, next Q2, right? Q2, okay, the energy here is not to change the temperature but to break the molecular bonding of the steam. Alright, so it is equals to ml. But since here, okay, the steam, okay, change phase to water. Right, so therefore the sign is negative ml, ml subscript v, vaporization. Alright, so ni negative ml v. Alright, so we have negative m. Okay, lv is latent heat of vaporization. Alright, you can refer to the table, okay, provided in the textbook. Okay, 2.26 times 10 to the power of 6. Alright, so next Q3, okay, to find Q3, okay, meaning the energy required to decrease the temperature from 100 degrees Celsius to 50 degrees Celsius. So we have this one equals to M. Okay, now it is completely become water, so it is must be specific heat of water. Alright, so the change in temperature is 50 minus 100. Alright, so here we have M. Okay, specific heat of water is 4186. Okay, and then here is negative 50 degree Celsius. Alright, jadi Q1 okay, plus Q2 okay, plus Q3 adalah Q hot. Okay, sorry, Q cool. Okay, Q cool. Alright, because the heat is expelled from it, isn't it? Alright, so ini adalah Q cool. Okay. Now, next we are going to look at the other two substances. We have water and glass. Okay, so dia bagi water dengan glass. It is not a calorimeter, tapi dia bagi glass container. Meaning we have to assume the heat transfer between the between steam and the glass also. Alright. So kita ada glass ataupun water dekat sini. Alright. So here we have T and then Q. So the heat from the steam will be transferred to the water. As a result, water will increase temperature, okay, from 20 to 50 degree Celsius. Alright, so the glass also will absorb the same amount of heat. Right, so dekat sini kita ada Q water equals to MC delta T. Alright, so ini adalah mass of the water, that is 200 gram. Alright, so dekat sini 200 grams equals to 0.2 kilogram, and the specific of water, okay, 4186, and then delta T is 50 minus 20, that is 30 degree Celsius. Alright, untuk glass, alright, untuk glass we have mass of the glass is 100 gram, okay, so 0.1, okay, and then specific heat of glass is, alright, so you can refer at your textbook apa dia specific of glass, okay, and then the change in temperature is also 30 degree Celsius. Alright, then only we apply the principle of conservation of energy, okay, that is, alright, Q cold, okay, equals to negative Q hot. Alright, so ini Q hot sebenarnya. Okay, ini Q hot. Okay, because it comes from hot temperature. Alright, so ini adalah Q cool. Alright, ini adalah Q cool. Alright, so Q cool equals to negative Q hot. So meaning that we have a QW plus the energy from the glass equals to negative, okay, Q1 plus Q2 plus Q3. Alright, you substitute all the values here inside. Okay, so finally you get the value of M. Okay, the mass of the steam, that is 10.9 gram.